Nice to have everyone here with us this morning for a great presentation from Nudura and Island ICF. Just a little background for you, as many of you know, Nudura and Island ICF are both sponsors for the BC Association of Building Designers, and so we appreciate very much their support for our association that makes not only this presentation today possible, but many of the other presentations and things that our association does possible. So thank both Island ICF and Nudura for that. We have representatives from Island ICF with us this morning, and as well, our speaker this morning is from Nudura. This is part of a two-part series. The first part, the whole program is called Design Onboarding for Building Designers. So it's to get you familiar with designing with ICF and some of the things that you have to understand how you can fit it into your projects. So it's a two-part series. Part one is today. It's ICF Construction. How does it fit in? It's a little more about the history of ICF and the development of the product. Part two is on May 7th. If you haven't already registered for that, it's in our upcoming events section of our website. It's Principles of ICF Integration. It's going to get a little more technical for you as designers, and some of your questions today may be answered on that second presentation. So part one is today, part two is on May 7th. The videos as well will be posted in our educational video section of our website. So if you, for some reason, need to leave early, you can watch the event recorded. Now we'll get into introducing our speaker this morning. We're privileged to have with us Eric Lemaire from Nudura. Nudura is part of the Tremco Construction Products Group. Eric has spent his career in the world of architectural design and is currently the Canadian Commercial Development Manager for Nudura. His presentation will discuss the evolution of the insulated concrete form industry from both the manufacturing perspective as well as the building code compliance. Although commonly used in single-family applications, several examples will be explored that show the use of Nudura in commercial, education, and multifamily settings. And by exploring the advantages and challenges associated with this type of construction, Eric will highlight the importance of well-planned design and the versatility when incorporating other building systems, as well as the efficiency with which these buildings can be constructed, and the long-term durability and reduced operational costs of the finished product. Now, I know for our company, we have been speccing Nudura ICF blocks for the last 15 years. As Nudura is a sponsor, they are going to be talking specifically about their product through the presentation, and that's allowed. And we are, again, thankful to have them with us this morning. So without further ado, I'm going to turn the spotlight over to Eric. And again, if you have questions, please put them in the chat. There will be a question and answer opportunities at the end of the program, as well as Eric will answer your chat questions through the program. So Eric, take it away.
Great. Just to make sure that am I not on mute anymore?
We can hear you loud and clear, yeah.
Perfect. And I'll probably get one more, make sure this is okay. Am I sharing my screen or is it the slide screens?
Yeah, you're perfect. Yeah, you can, there is a little button at the bottom that you can click hide. It says app Zoom is sharing. You can just click that hide note and it'll get rid of that little.
All right, let me try to slip on over there. Whoop, for some reason it's not allowing me in there. There we go.
Yeah, there you go. Okay, you're good. Take her away.
All right, great. Thanks a lot, Tony. It was a great introduction. I have no clue who might have wrote that, but it was really charming. That's, of course, it's going to be me. Thank you very much for everybody for attending today. Tony outlined pretty well what we intend to do today. The introduction does include both presentations we'll be doing today and tomorrow. And again, just to reiterate, I'll try to break these apart. There are many overlapping portions. It's kind of difficult to talk about one thing without accenting or talking about the other. But today I'll do my best to focus on the beginnings. What's the beginnings of ICF? Where does it come from? How's it made? A little bit more intricate, kind of those type of details. And then again, just to repeat what Tony was saying earlier, is that the second portion will be a little bit more towards the design. What do you do prescriptively? What do I do with the experience that I've got so far? And those will be details and procedures that I will be more than happy to share with you guys. And again, the last repeat or the doubling of messaging here is that throughout the presentations, I will stop every now and then and ask Tony if there's any questions, immediate questions. So if you do got one, it's more poignant towards the information I just shared. Put in the chat. Tony will stop me if ever we needed. Otherwise, I'll just stop periodically and address those questions as we go, so we don't lose the message. Before the presentation, every time I try to bring up a new phrase or slogan to kind of like prime the messaging that I'll be presenting today. And probably one of the better ones that I found lately is stating that what I'd like to do, what the information we'll be sharing today is to calibrate an understanding. And the reason why I'm using calibrate and understanding is because we may have an understanding of one particular thing, but we may not have it for another. And so therefore, we may refer to what we understand to better understand what we don't understand. I hope that made sense. So you try to find a calibration. How do you balance that amount of information? So what I'll be providing today and in the sequential second step of our presentations will be just that. I'm not going to convince you that this is the cure-all, it's the best thing on the planet. But what I'm saying is that it's a great alternative and it is a future-proof type of a product. But we need to make sure that we have a consistent and calibrated understanding. And so that's why I put that on there. So I just want you guys to keep that in mind as I present the information. The next little tidbit I love putting into place. You'll see every now and then I'll throw these in there, but certain of our leaders, either we believe in them or not, or they're industry leaders that we approve of their products or not, they do have some good minding in regards to how did you bring this product to fruition. So I use Steve Jobs as an example. I think we all understand what his contribution to technology is, but to surmise one of his quotes, it's difficult to make something simple. And so beyond the calibrate the understanding, make sure that we get a good balance, a seesaw of information. I also want to make sure that I'm trying to make this presentation as simplistic as possible, but it took a lot to get to that point.
Outdoor projects are exposed to sudden weather shifts. Storms hazard.
Was that Steve Jobs talking? Tony, did you hear that extra voice coming in?
Yeah, I think that was just someone had their mic on by accident. It's muted.
Okay, I thought maybe it was Steve Jobs talking from wherever he's at right now. Okay, so the whole idea is that it's difficult to make something simple, but in the end result, that simplicity should make things a lot more effective in the long run. And so with that being said, we have to consider saying, why are we actually looking at insulated concrete forms? Well, there's going to be 4 particular points, and not necessarily in any particular order, and it's not limited to just these 4 points, but these 4 points are fairly strong. Is that if we're looking towards insulated concrete forms, rather than a standard built cavity wall type of construction, we're looking for energy savings. And in those energy savings, built in by having energy savings, you subsequently get cost savings and you build a little quicker. You have less components that you need to consider. And then there's a long-term value associated that with also. We will explain in regards to durability and resiliency of a building built with insulated concrete forms. But the big idea behind that is that if you got that long-term cost value for your project, it's easier to amortize maybe an initial uptick in costs. It's not always more expensive to work with insulated concrete forms, depending on who you work with. Even so, if it is subsequently just a tad bit more expensive, it's easy to amortize that over the lifespan of that building. If you're building for more than 50 to 75 years, you're actually building a building that can sustain up to 300 years of durability, not to mention its resiliency. And then you reduce its ecological impacts. Now, either embodied or operational, I'll speak a tad towards that in the middle of this presentation, but basically is that we have to consider that we do have products that is considered environmentally questionable. It's a plastic, and we've been trained pretty well into understanding what are the downfalls of plastics, but I will explain what might be the advantages, how to use these downfalls to your advantage. So I'll explain that a little bit more down the route, but the basis for comparison is that we'll talk a little bit more in regards to price, cost, and value. So your price is going to be the initial reaction that we have to how much does that actually cost? What's the price of that product? Then you have the cost. What is the consequences of that price that you just paid? And then the value. How long does that cost last for you? So these are little elements that we'll be touching into and out of during the presentation. Keep these in mind in the back of your mind just as we go through and go further through. What is an ICF? I will take a general overview in regards to exactly what is an ICF. I'm taking for granted that most of the people on this call already has a good basic knowledge of what insulated concrete forms are. But in summation, in regards to what they are, they offer you 6 basic construction elements for the envelope of your building. The first one will be your concrete forming. I think we all understand that, hence the name, insulated concrete forms. Reinforcement, placement, and alignment. There's no need to offsite build a cage or to supplementary support vertical, horizontal rebars. It's already integrated into the product to afford you positioning for your bars. And then once the concrete has been placed in those reinforced cavities, it leaves you with an opaque wall, which is structurally reinforced, a monolithic concrete wall, which offers you different types of advantages, either by shear or by environmental separations. Is there monolithic, is pure. And then the fourth attribute would be the insulation, either inside or outside. Fifth would be the fastening strips. Now, keep in mind, what was at first the positioning for your rebar now becomes fastening strips. So everything that we have, insulated concrete forms, will have multi-purposes. It's not a singular purpose product. Everything that's integrated in that will have more than one purpose. And so that's what we'll explain a little bit more in regards to the efficiencies of working with insulated concrete forms. And lastly is the environmental separation. So basically it's the air and the vapor barrier. You're afforded both of these elements by default just by using insulated concrete forms. And the cool thing about this is if you take these 6 different building elements on either side of the building envelope, they can be all installed by one subtrade, just one singular subtrade. The product is fairly simple in its nature. Again, keep in mind that it's difficult to make something simple. There's a lot of engineering involved in getting this product that looks fairly layman in approach, but there's a lot of technology involved in this. It's consisting of 2 insulating panels on either side of the axis of mass for the opaque wall, and that's going to be made out of expanded polystyrene. That expanded polystyrene for Nudura alone will be 2 5/8 inch thick on either side of the insulated concrete form. We do have a product here, accented in my second point here, that actually go to 4 inches thick, and I'll explain the reasonings why we have for that. The expanded polystyrene is type 2 closed cell foam. That's going to be important in regards to what ULC standards we have to abide by. And also is that the webbings themselves are made out of polypropylene. So we have a mix of polystyrene, expanded polystyrene, that makes the insulation. And what makes the webbings or the fastening strips is going to be polypropylene. The polystyrene is extremely recyclable, so we have to keep that in mind. And it has the recycling sign of PP. And then the polystyrene, the polyethylene will be polypropylene for PP. So that gives you an idea what the recycling signs are. So if you look at for PS for the recycling of EPS foam. Innovative design, I think that's a pretty exclusive feature towards us as of late. It offers you hinging potential. So the form itself, even though it has 2 5/8 on either side, and if we take, for example, a 6-inch core, it'll give you 11/4 inch thickness of material, of product itself. If you're trying to ship that, you fold it flat and becomes substantially less thick, affording you a little bit more product on every truckload. And keep in mind, the EPS, the polypropylene, they're both highly recyclable products. Specific standards towards our forms themselves, and basically for every insulated manufactured product that they provide for insulated concrete forms, most manufacturers will start with a core of about 4 inches thick, and it can go up to about 12 inches thick for off-the-shelf type of products. That's something you just say, hey, I want to buy it. I don't want to assemble the thing. I just want to put it on the footing, and I want to start my construction. We at Nudura, we offer 4 to 6 inches. It's always in multiples of 2 that we offer these different kind of core sizes. For Nudura, specifically for Nudura, we offer 3 different form heights, starting at 3 inches high. 12 inches will be your next step, but 18 will be our flagship. So 1.5 feet high is the predominant product that we use for the majority of all our construction requirements. The 12 inch is great when you have to hit a specific certain height, say at top of wall, or if you're just building the foot of the foundation and you need to have it in exactly at the right spot. We do offer a 12-inch form that's already pre-manufactured. And then the 3-inch one is really just that. It's that finite type of an adjustment under a windowsill, or if you're really trying to hit a deeper lintel height at your upper level. There's ways to integrate these different products. But I would say by far, the 8-foot long, the 96-inch product that we have for our standard lengths, and the 1.5 feet or 18-inch high or tall measurement for our product is our standard. For most of our product sales, it will be the 2 5/8. So we consider that our standard product. The 4-inch product that I had mentioned earlier, that'll be how thick the inside or outside plane will be. The 4-inch product, we call it XR35. So it's a Plus Series product that we have. But also within our Plus Series, we offer different types of laminations, should ever that be needed. We're not the only manufacturer out there, and we'd be naive to think so. You do have choices, but within these choices, you need to have at least a good idea in regards to what differentiates one product from another. On the screen I have right now is just a snapshot in regards to what's available in North America. There is substantially more than that globally. I could easily say that Nudura as a company will cast a shadow across most of all these products predominantly put together. So we are a global leader when it comes to insulated concrete forms, and we do consider ourselves as the innovator. Within these types of specification or comparison charts, the big things to keep in mind are how tight the ties are. Are they 8-inch, 6-inch? Are they more than that? Less than that? Performance data in regards to what do they have for accreditations and certifications for requirements. But most importantly will be what are the typical dimensions of that product. That will help you down the roads in regards to designing more efficiently or figure out which one's a lot more efficient to just put in place. What's its efficiency rate? But there is availability here of choice. So then it's nice for competition. It's great for innovation that we're not the only ones there. But we do have to make sure that the customer always understands that there is a choice. Insulated concrete forms is not new. It's been around just about as old as I am. I won't say 1945 as a birth date for me, but I can definitely say somewhere here within 1967 is when we first saw the variant, more or less the cousin version of what we see nowadays using in North America. There are different types of insulated concrete forms, but the basic form of it as we see it right now, 1967, and it was actually in Ontario where it was being used, first one in the world in North America. The origins of the chemical makeup of the different type of products, either polystyrene or polypropylene, dates back well over 100 years. And there's different types of benchmarks here in regards to when do these chemical companies start catching up with making these a more viable type of product. Every time that we bring something to market or we invent something, it looks great because we see the benefits of it. We need to make sure that we also understand what are the drawbacks of it? Where are the negative factors of these? And so as we evolve with these products, every time we have a different type of a benchmark, there is evolution in regards to better understanding the product. Hence the reason I mentioned calibrated understanding. When I mentioned there's different types of insulated concrete forms, not manufacturers, but types. 3 major types pop out in regards to what are the variants that we see nowadays. The first and foremost one would be this kind of screen pattern. So you're seeing basically beams and chutes or columns, flutes, sometimes they're called. So they're basically columns and rows of insulated concrete forms. So it's kind of like a waffle or like a grid pattern. When you take that and you evolve it a touch more, you need to get a little bit more ligaments between these columns and these rows. Then you create this kind of waffle grid. So you'll have a column, a beefed up column to place for compression. And then you'll also have these rows or these beams here helping with lateral forces or transfer of loads. But as you're trying to get these kind of bracketries between them, you actually infill them. So this would be the waffle grid. And we're not seeing much of these days. But what we're looking at predominantly right now, a good 95% of the market, will be flat wall, just particularly flat wall. But as I explained, Nudura in particular and the insulated concrete forms available to you on the market nowadays, I will go back slightly to the screen grid because this is kind of making a little bit of a comeback. So I'll explain that. Why am I making that seem so interesting? I'll explain that a little bit later. When you're looking at the flat wall insulated concrete forms, once you've made that choice, I want to have insulated concrete forms, and you choose from one of those multiples of manufacturers I showed a little bit earlier. When you look at the different dimensions and the specifications of those products, it's the way that they are delivered that makes a difference. And there's 3 major separators in regards to how is the product brought to the work site. The first one would be a site assembled version. This one could be akin to IKEA. It's that little guy in the corner pointing at a bolt that he wants you to put in the right spot because he's only giving you the parts. It's not pre-manufactured. You're just buying the parts itself. So when we looked at the price, the cost, and the value, this one is always considered when it comes to price. Not very expensive to purchase, but then it could have residual effects when it comes to actually assembling it and putting on site. Say if you take care of that assembly and you already have it all assembled, and you look at a product similar to the preformed, fully assembled products. Now, these come a little bit more viable. These are already pre-built, so you're not investing on site for those particulars for assembling these together. But also the ick that we may have with this particular form is that you have to ship these to site. They take up volume. And for the most part, they're not nearly as long. These pre-assembled products typically tend to be just shy of 4 foot, if not 4 foot. If we look at the third variant, the third option we got, fully assembled, much bigger product, but also hinges. What makes this one a lot more interesting is that you're getting a lot more product for every action that you take. If you take that form and you put it onto the footing, you're putting a lot more product or a lot more square footage of wall surface area at one particular shot. And you're getting a lot more on site because you're shipping a lot more product and make it more efficient to make work site management. If I've got a bunch of these products right now that are taking up all this volume, I have to put them somewhere while I'm using them, and they take up space. So when it comes to work site mobility, other considerations to take into effect. So 3 different variants. We, Nudura, this is to be the one that we do. We also offer a unassembled version, not completely knocked down as this one is, but we do offer a unassembled version which offers just the panels and just the webbings themselves. So even though we claim that we are great for certain attributes because we fold, we're a much bigger product, but we also understand that there is a need for variant 1 and variant 2. There is a need for that. So we don't want to be focused solely on that. But we are the only ones that offers this style and this size of form. It's great to offer straights. We can't build homes with just straight lines. We have to be able to provide for different shapes and different forms. That we offer standard products, which will be our straight line product, but the 90-degree corner will be the one that really has shouldered the majority of the work that we are involved in. The straights and the 90s are the ones that we use most often. But we also offer a 45-degree angled form, pre-manufactured, and these both come folded. Keeping in mind, these come folded. They take up less space. Within these variants here, nothing stops you from way of design. We'll talk about that in part 2 as a teaser. We'll talk about part 2. You're not limited to just 45 or 90-degree angles. You can build insulated concrete forms and find the finesse and the subtleties of angles that you'd like to have to expressed through your drawings. So we're able to provide those. Not only are we able to provide the 90s or 45 or different variants of site cut angles, we're also able to offer radius forms. Radius forms by most manufacturers, they're either made in the manufacturing facility for the most part, but we offer either pre-made or site cut variants. So we'll offer the plans to say, cut this much out of each segment and you'll have the curve or the radius you need to have. Within the family of straight products and also shouldering a little bit on the 90s is that we offer taper top versions. The taper top version basically is our standard form, but it allows you to have 2 inches of supplemental bearing surface at the top of the form. And if you use these on both sides, you're getting 4 additional inches. So it just gives the variables in regards of designing, having a larger bearing plate or bearing surface without distortioning the profile of the wall assembly itself. But if distorting the wall assembly, creating a little bit of a corbel or a distortion of axis of mass is appropriate, then we also have the brick ledge. The brick ledge is exactly what it says. It's there to support some brick. It can support very easily 27 feet or 3 stories worth, which is code requirement. And it's very easy to work with. It comes pre-assembled or it comes unassembled. And it can be used in different variants. If you're bearing a load, if you wanted to make sure that that slab doesn't slip back down into earth. And so we got reasons to use that. There's variables to it, but it's the brick ledge is its primary use. And probably the most romantic one, I think, of the whole gang here is that we offer a one-sided version. Most manufacturers will offer all these products, just to keep that clear. Most of them will. But we're very proud of the 1 series form, the way that it works, its efficiency to have it put in place, but the ease of erection that we have with these builds. They're very easy to put up in place and build up your buildings. The panel itself is designed to be removable. You do not leave this in place. You could leave it, but there's absolutely no reason to do so. But the whole idea behind that is that you'll have the concrete exposed to one side of the wall assembly. Predominantly, these are used very, very often in elevator shafts, If it's a stable, it could be used as a kick wall. It could be used in stairwells, or it could actually be used for decorative reasonings. If you really would like to have that concrete exposed, that could be a good product to consider. I mentioned earlier that we have 2 5/8 as a standard. We have our Plus series, which is 4 inches, which now becomes a little bit more standard for us. But there's other variances that are available. And keeping in mind, when I talked about calibrating understandings, making things simple that might be difficult, there is evolution involved. And so we perpetually try to innovate and better our products. So as we go forward, we try to get a little bit more prescriptive R value, because our codes are based off prescriptive R values predominantly. That we needed to get a little bit more R value out of that wall assembly. So we brought to market a core insert. And this hence is exactly what the name states, is that you place this inside the core, which reduces the core size to whatever size you need to have. So this form needs to be larger than what you're actually achieving, considering what size core that you want to expand. We offer these in 2-inch multiples. They're a little bit cumbersome to use. And once we found out that, okay, we got a better evolution of product, then we keep going forward. But this allows you to asymmetrically balance the wall if ever you need to. It keeps the streamline of that product very slim. And also that it allows the fastening strips, which are embedded into the polystyrene panels, to be fairly shallow from the surface. And that's very important. The next product we've got would be our standard form, but with a lamination. Again, most manufacturers will offer this type of technology. This lamination basically is 2-inch multiples, but every time you use the lamination, that fastening strip that's embedded into the polystyrene becomes that much deeper. So you have to consider shear at that moment. How much cantilevering is that actual anchoring system providing for? So the lamination is selectively used. Both of these are basic evolutions. That leaves us to the third product, the XR35 that I mentioned earlier, our 4-inch product. So this one here will be the viable product. And the beauty of this one is that the fastening strips become larger. And so they remain shallow from the surface of the EPS. Makes it easier to anchor any kind of accessory that you need to anchor to it. We do have accessories. We cannot have insulated concrete forms without anything else. You've got to add features to it. So we do have some galvanized steel products that help us transition from core sizes. Either it be this type of bracket you're here. We do have bracketries to hold onto your rim joists or your flooring joists. This product down here is not our product, but I'm just putting it there to accent that there's different ways to support a rim joist. And then also bolts and snaps and clips and adjustments and alignment features. We have all these available. Calling your local rep, calling your local distributor who's on the phone, who's on the call with us today, will definitely help explain a little bit more in depth in regards to when, why, and how to use these different accessories. But we cannot live insulated concrete forms without these particulars. Is there any questions so far in the chat, Tony, that I could address before jumping on the next one?
No questions so far. I think everyone's just captivated.
Oh, great. That's awesome. They're all leaning in. So I'll go towards applications. I think it's fair to say that, residential construction will be a strong suit for us. Anything within Part 9, we do offer quite a bit of information to achieve those. But for the most part is that we tend to be associated, because we're concrete, to foundations only. We need to demystify that. Come back to the calibrate the understanding portion of it. We need to demystify that we're only good and suitable for below grade applications. We are definitely great for grade applications, just to make sure that we make that clear. But nothing stops us from going beyond that and going higher up. We know the value of insulated concrete forms in ground, in situ. But then if we're able to extend those benefits up and outwards from the ground, then we're definitely going to be capitalizing on performance. But again, the word concrete may be something, has some complacent or lingering psychology associated to it, that people might associate that to something cold or a parquet or something like that. No, there's absolutely no reason to think that. We need to demystify that. So I've given some couple of examples here on the screen. The pool itself is just to show that, yeah, below grade, but we could do subtleties of features. Curves and radius walls that I mentioned earlier are definitely a strong suit for us. We can achieve these very easily with insulated concrete forms. If you want contemporary design, we can provide that also. You cannot tell this home is built out of insulated concrete forms. Conventional design, no problems with that. And then also a little bit more radical, a little bit more modern type of a feature. Nice radius, soft curves here, but very pointy. We can achieve that with insulated concrete forms. And also you can see the large expanse of openings. You could definitely accommodate these large openings too. So we're not limited to below grade. We can do fluctuating elevations, step foundations, step walls, retaining walls, really large openings. The sky's the limit, honestly. There's not too much more we can't do. I would say the only limit we've got on these is very large or long cantilevered walls. We can engineer those. Keep in mind that concrete is a transfer beam. But we could touch on that on the design features. Again, I'll leave you guys some teasers for the next one. Outside of residential construction, commercial construction is definitely another strong suit for us. So residential, commercial, we can fit just about every gamut of that. It depends what occupancy you want to have for that building. The building is essentially, if I break it down into basic terms, it is a box. It's a shoe box with a cover on it. Once you put that cover on there, then you start to deal with racking or design diaphragms that you need to consider for the building. But everything you build is dependent on its occupancy. So if I have this list of different types of buildings we could build, it's just the occupancy of that build. If it's medical for long-term care facilities, yep, we can control that environment very comfortably and actually let the residents themselves contribute some BTUs to that building. The last point that I have here is safety, the storm centers or post-disaster buildings. In Canada, we don't necessarily have different types of hurricane or tornadic event requirements, nearly as stringent as we do in the States. But we can act, our buildings can be designated as post-disaster should it ever happen. Down in the States, we actually become storm shelters. So there'll be two different variants of how those buildings are designated. One is to withstand the event, and the other one is what to do after the event has occurred. But you need to have a building that's resilient enough to withstand that event. So the storm shelter, take shelter, and the post-disaster is that you have a safe building from which to muster to. So keeping in mind, we're not limited to any one of these different types of occupations, but we have to put those in there because different firms may actually focus on different things. But the residential side of things, it's very simple for us to achieve those. It could be multi-residential, multi-level, or single-family home, duplex, whatever it is. You could reach out to either myself, Daryl, Shane, even our local rep, Kristen Griffin, and any one of us will be able to guide you in the right direction. Now, we've looked at the outside of the build. We've looked at the profile of it, and yeah, we can make it cool. We can make it great and groovy, and everything looks great. What do we do on the inside of the building? So everything here that we have in the black line, the building envelope, no problem. We don't really have much issues in regards to obtaining the structural requirements for a build and actually the performance requirements for a build. But also when it comes to interior divisions, predominantly in a commercial building, when we look at demising walls or corridor walls or elevator shafts or stairwell shafts, we can accommodate those. When it comes to residential construction, if you have to build a party wall, fire-rated wall between two different Part 9 builds, we can accommodate that. When it comes to STC values, why am I looking at these demising walls? Because I can offer a minimum of STC 50 and up to 58. So we're able to accommodate either the 2-hour fire resistance rating, the minimum 50 STC ratings, 55 when it comes to an elevator shaft next to a suite. So we can accommodate these quite easily. So exterior walls, number one, easy to get to, either a home or a commercial build. Demising walls, partition walls, predominantly party walls for residential sides of things. It could be the wall separating the home and the garage. But the demising walls will be the second focus of attack, I guess we could say, by way of walls that we can address. And when you go upwards and a little bit higher up towards commercial builds and corridor wall requirements, we can do those depending on what the parquets look like underneath the build. So we have to look at the structural diaphragm of that building. Can we accommodate that transfer of weight? All being said is that we can accommodate a majority of situations. We talk about, we got these great buildings, we got designability. I can give you some stuff that says, hey, I can design this, no problem. So if you look at designability, we have to consider permissibility afterwards. I can design it, no problem. Am I allowed to build it? That's the other thing. So acceptance criteria, that will be important for us. As an industry, insulated concrete forms are written within code. We have a separate section for us within the National Building Code. Almost each and every provincial building code will include us also within Part 9 of the building code. Within that Part 9 of the building code, there'll be stipulations for two different things. One will be foam plastic insulation. You have to have certain norms to actually use any form of foam plastic insulation. And the second one is predominantly towards insulated concrete forms. So within these I know it's a little bit small over here, but the nomenclature that's within here will stipulate that for your foam plastic insulation, ULC 701, you have to have those criteria met and passed to be able to be acceptable as a foam plastic insulation. We use foam plastic insulation, so we have to have that accreditation. But we have to take it a step further. Within the codes themselves, there'll be another one here, ULC 717. That's important. When you look at the different manufacturers that are available on the market, if they don't have a minimum of ULC 717, the impetus and the responsibility is on your shoulders in regards to the performance and the acceptance criteria of that particular product. The ULC 717 basically lumps in all the testing standards and compliances that I'm highlighting over here, all in one shot. It basically says if it met 717, it means it met the fire resistance rating, the assembly thermal resistance, the wall assembly sound attenuation. That could be the ASTC or the STC. The fastening strips with withdrawal resistance. So flame spread, smoke, all that has to be approved to be within the 717. After that, you'll have different attributes in regards to how do you protect it, how does it perform. But you have to hit these minimum requirements. These are afforded to you through either one of us, either myself or the people I mentioned a little bit earlier, or even on our website. But you have to hit these criteria. So we have designability. I could do the design. I need to have permissibility. And this is where we can prove that, yes, we adhere to the standards and criteria of ULC 717. Beyond design, beyond permissibility, and I'm very strongly convinced that within your area of expertise, environmental concerns have to be first and foremost. It has to be. And if it doesn't have to be, it's going to have to be. Us as a company or as an industry, we're a little bit lethargic to come to terms with it, or at least to have a good comprehension. And I'm not speaking about insulated concrete forms alone. The construction industry in general is fairly lethargic and has a lot of lingering psychology associated with standard builds. What I will talk about in these next couple of slides in regards to our positioning, Nudura, and predominantly, in addressing how do we go about expressing ourselves ecologically. The building code, the resiliency of the building, that's where that's being addressed. How durable is it for safe occupation? Energy codes will basically address the operational side of things. How does it perform? What's the minimum so that we're not expelling too many operational negatives than we should be? So the operational side of things. The embodiment and operational of carbons is going to be addressed within the energy codes. We can validate and certify what our positioning is for the environment. So if we're able to get permissibility, then what's stopping us from going a little bit further and actually having more than just 2% of the construction industry? It's complacency. I'm 100% sure of it. We are great as humans at learning things. We are terrible at unlearning things. We tend to stick with what we initially learned, the energy that we put forth towards that, the embodiment of knowledge, and we want to stay with it. We kind of want to stay with that. But even if we are inquisitive and we want to learn something else, we tend to refer to that first thing that we knew to start to comprehend what's this new objective I'm trying to achieve. And a lot of times, I think strongly, professionals just don't want to make that leap. We'll be reactive until we're mandated to be proactive. So strongly, in my opinion, the cut and paste mentality and complacency in construction is probably our worst opponent so far. And today we're just trying to at least express a more knowledge, calibrate the understanding in regards to we can be designable, we can be permissible, and we can actually be within the realm of transparency to say, here's where we position ourselves, here's where we stand. So when I talked about we're a plastic as opposed to wood, as opposed to steel, as opposed to concrete. We are the plastic industry. How do we fit within the ecology? But within our product, we're wholly dependent on concrete and either steel or more plastic for the GFRP. But for our portion of the environmental stance, what's the ecology? How do we impact our environment around us? We have to have transparency. So as a company, we are collecting information, we are gathering requirements, we are meeting these challenges for different I can say programs, not necessarily the passive house, but the building challenges that we have by providing either declare labels, certifying and attesting and demonstrating our ISO compliances, These compliances right now will actually lend us to be able to express an ICC rating, which is more or less for the states. We can declare our transparency and commitment to better management of our manufacturing, but all these culminate into an EPD. The EPD itself is going to be the next documentation that's, I strongly think, and again, based on knowledge we have for the 2025 version of our codes, we're starting to see different acronyms appearing. The EPD is going to be one that's going to be a lot more predominant, and also EY. I'll explain that a little bit later, what that is, but basically for energy consumption. But the EPD is an important document, and we at Nerdura, we are the only one in the manufacturing industry of insulated concrete forms that has one. It is your nutritional label. You're buying a bag of Smarties or Skittles, you're going to have the nutritional label on there. You got to be able to express what are the ingredients of that building. Not how you're making it, not the secret sauce, but what's the caloric intake. So you could tell and judge for yourself what are the negatives of ingesting that Skittles. How much is it going to draw me back? Same thing with the products that you choose to put in your build. You can choose and balance the pros and cons of each and every product you choose for that building. And when I said complacency comes into place as a handicap right now, this is where I definitely see that being into effect. We can declare and express every value that we've got within our product. So either it be the primary components of the polystyrene, polypropylene, or the secondary components. What will be the expansion of our beads? How do we do it? What's the manufacturing of it? All that is expressed in declared units, and it's all expressed in regards to what is its CO2 equivalent in regards to what do we displace from the atmosphere, or what did we actually use to make our product. So there's different expressions in regards to where we are, but always keeping in mind our product, the way that you see it, the way that I'll show examples of it a little bit later. Polystyrene in general, expanded polystyrene, not extruded, expanded polystyrene is only 2% material. That's very important to consider. Even though it takes up a lot of volume, it's only 2% material. This EPD right now basically declares that we have the equivalent CO2 equivalents of polyethylene, which is your vapor barrier. Complacent construction, contemporary construction, the hollow core, not hollow core, but the cavity wall type of constructions are always reliant on polyethylene. If we're willing to put vapor barriers and air barriers all over our general assemblies, we can't be looking at insulated concrete forms negatively when we don't have that much more of an impact. So the EPD is going to help us out in regards to taking a stance and actually declaring what is our positioning. Hey, Tony, I think I saw a question come through the chat. Is this something relevant to what I just talked about?
I think we'll let you get to your next pause slide, and then we'll deal with some of these. Some I think we'll save right till the end.
Okay, great. Hopefully you guys are still with me. I warned you guys, it'll be a little bit nitty gritty in the technical stuff. The second one, I'm definitely teasing you guys for the version 2 of this. We'll get more into the design of things, but I think it's really important to at least understand what are you designing with. My experience within architecture, I remember when I first did my stage with an architect, he had me drawing door handles. I had no clue what in the world I was drafting, but I was drawing these nice little circles. I had no clue what they were. And I just find it important to better understand what it is these lines actually represent. So we can make these great drafts, we can adjust it, it's all symmetrical in a whole kit, but what does it actually contribute to the environment? So all that being said is that insulated concrete forms perform. That's where they're very, very known for, if that's proper grammar. They're well known for, that's probably better. And how do we go about hitting that performance levels? It's pure and simple, it's mass, thermal mass. It's kind of like this geothermic reaction. We all know it. The basement's going to be a little bit cooler, a little more steady than once we get above grade, and we understand why. A cave is always pretty much steady. It's geothermic reaction. So it's creating that mass for thermic reactions. Insulated concrete forms work on simple processes that are similar to that. It's akin to it. So if we look at standard construction, 2x6, vapor barrier, infill insulation, the whole kit, you're only accumulating about 2 pounds of mass. That's all you can accumulate. Insulated concrete forms, the concrete itself, for a 6-inch core per square foot, will garner you 75 pounds of mass. Why is that important? It's inertia. It's the same thing as a bowling ball and a ping pong ball rolling down a hill. One's going to be simpler or easier to influence than the other. The ping pong ball, you can blow on it and change its direction. You can't do it with the bowling ball. It's got this lagging inertia that just wants to slowly expel itself out from it's not a kinetic energy, but it's an inertial type of an energy. So it wants to resist change. That's important. The more mass you got, the more resistance you can have to change. That change can be understood, calibrated. Come back to that word. Our codes are prescriptively based codes. No matter how we look at a wall assembly, it could be this cavity wall assembly, it could be insulated concrete form assembly. If they both have a theoretical nominal value of about R22, I'm just taking the average of these two because this is a little bit less, this is a little bit more. So if I'm just taking a nominal value of R22 and I say my prescriptive code says these two wall assemblies are going to perform the same way, great, fine. But what actually happens in field? There's a test for that. The ASTM 1363 basically includes two different chambers, very cold, -35, very warm, +21, and you have the center wall. That wall is the walls trying to resist the heat going towards the cold. And you can measure that. You can measure that. So if our value is the basis of comparison that our codes provide us, no matter how you add up the R values, these two should be the same wall, theoretically. Put in this chamber here, it'll test the amount of consumption of BTU is absorbed by that wall once it reaches a steady state. It's at a point where it's consistent, it's absorbing, it's resisting that change, reduce its energy, take it away. How does it work? So we can measure that. The consumption of BTU, this line here that we see going upwards, is basically once that wall is at a steady state, it's resisting it steadily. Take away its influence, take away the energy. The power grid just went out. That wall itself, you can measure just how much BTU it needs to sustain that steady state to a point to where it hits the disbalancement of steady state. It's the opposite steady state. It's, the heat's all out of that room. It all went towards the cold. And you can measure that. So it only takes about maybe a little bit more than 2 days. It's out of there. It's gone. The BTU consumption of the 75 pounds of mass takes just shy of 2 days. That same almost equivalent time before it even shows a sign of life. Then slowly starts digressing towards steady state. What does that mean? You could actually put that into R value. So that nominal cavity wall, R value, nominally rated at R22, theoretical expectations are always not met, if that makes sense. If it says it's R22, in these third-party testings, they know that they're never met. The gas mileage on your car sticker when you buy it brand new, you know you're not going to meet that because there's a theoretical value and there's a performance value. Same thing for these walls. So just shy of that 1 day or 2 day mark, we're already under the theoretical value. That's understood. But you look here at the insulated concrete forms, that thermal mass. It takes 324 hours, the equivalent of 13 days, before it hits steady state. But within all that, you could see up here the 5 days worth of performance, you're exceeding R40. So on paper, it's R22. So insulated concrete forms with its thermal mass is very highly performing, much more than theoretical value of a cavity wall and even its own theoretical value. So it requires re-examination in regards to how these insulated concrete forms actually perform. If you take that information and term cost it out for 60 years, you compare a code-built building, high-performance building, and then take that next stage over and give it solar offset. You can also measure, theoretically measure, what will be the equivalence in savings. So I use this slide here just to demonstrate that all that performance data actually equates to something. It's that if you're building a building, and again, I know this isn't residential, but just for comparison, if you're building a building that you're exceeding $57 million, almost $58 million for that initial build for a typical code-built building, and you only add 5% to that major construction cost, $2.7 million, that sounds like an enormous amount of money. But it takes you less than about 5 years to recoup that difference just on performance alone for this size of a building. It's an enormous building. So it just gives you an idea that you can extrapolate information from that and reduce it down to a single family home or a duplex. So this kind of information is definitely available to you at any given moment. Now, design implications. When I look at this, I say, okay, where do we go? I mean, I'm talking to a design association today. And so I've just given you the vegetables part. Now you're eating your vegetables first, and then I'll get to the main course, which should be fun. And then the dessert will be the part 2. So within the mythology for insulated concrete forms, I do offer those same types of 5 different steps. So you choose it wisely. That's looking at the manufacturers. What are their spec? How efficient is it to put in place? How does it perform? Does it have its ULC? Design simply. The design simple part of it is that allow the product to influence somewhat of the design. Incorporate durability and resilience. Build more than just for 50 to 75 years. Build longer. Let that building withstand something that might not be natural. And then build it efficiently. Use the products that take up less space. And then innovate. That's more or less on us, but it's also on you as the professional and on the people that aren't on the call as the owners. Staying in tune with the Steve Jobs thing, I put the Cobra effect on here. Not sure if anybody's familiar with it, but to surmise it, basically, is that, and you can Google this, it's a true phenomenon. It's basically saying that the solution is worse than the problem. Are we trying to fix something that wasn't broke? So there's a document. I mean, the Cobra effect. You Google it, you'll find it entertaining in regards to why that exists and why it's called the Cobra effect. But basically, the solution is worse than the problem. And I want to make sure that that's accented, because if we're looking at complacent design, the one that's on the right now, you have to include 8 different steps to make that wall assembly work. It's one of those things that, like, hey, I'll put a bunch of sticks up there and I'll barrel some weight on it and put a roof. Oh, great. But there's holes all over it. All right, I'll put another thing and I'll plug up the holes. I'll put a membrane on the outside. Hey, I'm kind of cold. All right, I'll put something else in there. But now we'll put something else in there and now it's condensing. Oh, well, I'll put another thing on there. So you can just see how sometimes you just try to keep adding more and more Band-Aids to a situation. So then that solution starts to become problematic, because in these 8 different steps that's on the right, it requires variances of subtrades. And each one of these products have to work harmoniously in concert. If that vapor barrier fails, eventually that whole wall assembly will fail. Each one of these requiring subtrades, they're going to overlap on each other. And there's class management that has to be associated with that. As an architect or as a design professional, as a technologist, even as an engineer, if I want to reduce my liability on that build, the first thing I would do is learn to reduce the amount of products I'm introducing to that build. If I've got less products, more products doing multiple tasks, when I mentioned earlier about each of our elements does multiple tasks more than just a singular action, the one on the right is an assembly of singular purposed products. The one that's on the left, the insulated concrete form, is a singular product doing multiple tasks. Those 3 steps that I'm talking about is basically putting the form on the ground as 1, putting in your rebar as 2, putting your concrete as 3. All those together, you're getting 9 different elements. At the beginning, I said you had 6 different elements, but keep in mind, the insulation on the inside, the insulation on the outside is 2 different elements. Fastening strips, inside or outside, is 2 different elements that you don't have to pay somebody to go around that building to accomplish. Even though the price isn't that expensive, the cost is more expensive. So insulated concrete form just basically regroups that you're reducing your subtrades, you're reducing your potential for liability at failures. Your failures are almost always going to happen at interactions. More products you put in there, the more interactions you will have. Limit those products. By default, you limit your interactions. You limit your potential for failure, ultimately reducing your potential for liability. So insulated concrete forms would be a great choice in regards to reducing the impact of potential clashes. When we talked about efficiency for the product, fine, I can prove how it works. We talked about the price. Okay, we got an idea what the price would be, 1, 2 versus 3. When we look on the site, you can get a good idea here in regards to how much you're shipping for this. If you're only shipping maybe 100 square foot here, you're shipping several hundred square feet over here, all in the same truck. And then you could also see the site management. If you're looking at an equivalent amount of wall space and just how much you're taking up on this one here, you've got to take that into consideration. Site management is extremely important. When you look at the efficiency rate, basically the surface area divided by its perimeter, you take the whole surface area of this divided by its perimeter, it'll give you a factor. How efficient is that product to actually put into place? The higher the factor, the more efficient it becomes. So if you take a half the product, you can see it's not half of the factor rate, but it's just less efficient to put in place. Elements to keep in mind. When you're looking towards design simply, and again, please keep in mind, I will accent all of this in the second version of our 2-part presentation piece here. What I use this slide for is to basically reiterate, allow the product to have some influence on the design. When I went to school a long time ago, product should never dictate design. That's what I was taught. You need to have expression of flow, meet your construction requirements, and find an expression. That was great leading up to the 80s, what have you. And now we start to comprehend that, okay, this stuff's creating waste. If I allow this product to influence some of my dimensions of this build, I don't transform the silhouette or the architectural language I'm trying to express. I'm just pushing and pull it ever so slightly. I will reduce waste. And we understand that waste, when we throw that away, there is no away. We're displacing it somewhere else to have some kind of different effect. If we're actually using it, it does not become waste at that point. It does not become wasted money neither, because you're actually using it. So if you allow that product to influence and push and pull design, it'll be that much more efficient. And what you'll find as a consequence for ours, and here's where I have trouble when I go to schools, I have this other presentation called Allow the Fraction to Exist. And that's a whole little part. Because for our builds, we have fractions. If you allow the product to influence the design, you're going to see 1/4 inch, 3/4 inch multiples. Just the way our form is made, when you stack them together, you put them together, you're going to have the 1/4 inch. And for me, that's a sign that, okay, we've optimized that plan. It's not to say you're limited by our product. You can cut that to any shape and dimension you want. If you want to be pure 32 feet, just do it. You can do it. You can design it. You can cut wherever the form you want. You make this vertical seam. No problem. It's like you cut your Lego in 3/4, but you can't clip in the next Lego above it. You have to continue that seam all the way up. So you can achieve any multiples in any dimension you want to achieve. But if you allow the product to influence the design, you're going to have fractions. We all work in AutoCAD, Revit, ArcSoft, or whatever it is that we're working in, SketchUp. We can bring it down to 256th of an inch. There's no reason why we can't accept a fraction. It's an expression, an illustration of this is how long I want that to be. So you allow the product to influence the design. If I'm looking at the plan view only, great. Okay, I can make the Lego pieces work together. How do I make my horizontal surfaces interact with my vertical surfaces? We can accommodate insulated concrete forms in general, keeping in mind, well built, all insulated concrete forms are good. There are some that are manufactured more consistently. There are some that are easier to work with, but the industry itself is very proud, and you're offering a different construction style that will lend itself well to good performance. Now, the big thing that might be different is service. How much is this person willing to talk to you and coach you through it so you get a good comprehension of that? We can do that for you. And we'll express and expand and explain in regards to, yeah, we could do flat slabs. I got a detail for that. I'll show you how to do hollow core, steel. For residential construction, for the most part, you can have solid opaque wall. Dimensional lumber. It could be an engineered lumber. It could be an open web type of wooden joist. Any type of these systems are applicable to insulated concrete forms. The only one I don't have on here yet is CLT construction, which I'm working on right now, which we can do. And there's also another variant of that, which you actually have kind of like an insulated concrete forms for flooring. So we're working on those too. But I would say the top left here are what we're going to see the majority of the time for residential construction. As we're building up the building in our next segment, I'll demonstrate the detailing. For the most part, the walls are suspended by the floor, by the wall. They're not atop of the wall as with contemporary construction or complacent construction, cavity wall construction. So we'll explain as to why that becomes advantageous to you in the long run. So the floorings are more or less suspended by the walls, not atop of the walls. But we can accommodate a multitude of different construction styles. Top of the wall, again, we have options to that. We have different ways of achieving that, so that's not too much of an issue. It falls in line very similar to with the flooring systems. Resiliency and durability. Yes, we can withstand an event, and we're very easily rebuilt. So either it be fire, tornadic, hurricane, we are able to provide great data in regards to resisting a Category 5 storm, 250-mile-an-hour winds. And how can we actually design ourselves to actually be zero-scaping our designs and allowing that building to withstand an event. Building efficiently, we talked about that. We also offer methodology in regards to how do you deposit your products on your project, making that more efficient for you. We can explain that. But again, when it comes to innovating, it's on all of us. It's the professionals, you guys. It's the manufacturer. It's me. It's the builder. It could be Daryl on this call, the distributor, but also the owner. We're all responsible for innovating, and within that innovations, we do offer variant types of performance issues. So we can actually pre-cut your form if ever that need be. Ship less material, a lot quicker, more expeditious to put on place, and we're actually able to attribute any kind of waste to another portion of the build. Something we offer in regards of that. So we're able to innovate. And the biggest and most important part, when I mentioned it earlier, we're dependent on concrete and steel or GFRP. Complacent specifications are not all that great. You can alter those specifications to meet ecological criteria required for that build. Nothing stops us from changing how do we treat our novel binders. Are we going towards pozzolans or slags? Even biochar, that's something that's coming up a little bit more often now. The pozzolans are the ones that we're more familiar with. But you could change these novel binders. You have the access to change that recipe. You want less sugar in that cookie. That's exactly what's kind of working out here. And your aggregates. You got different ways of looking at your aggregates. And then the reinforcement. That's the big one. Because if you reduce that carbon steel, the coal necessary to create the heat necessary to make steel, go to an electric arc even, you're reducing every impact you've got on your ecology. So you've got different ways to make this recipe a lot more efficient and still get the flavor and the crunch out of it that you want to have. Sorry, it's like a nutritional thing. Because filling that nutritional label thing earlier. Sorry. So you do have options in regards to how do we go ahead and innovate and choose better products that fill and use with our products. I think there was a question a little bit earlier about membranes. We do go into this quite a bit because we are part of a bigger family group. Inside this family group, there's much more than just the 6 that I have here on the screen right now, but we do have accessibility to harmonized. Harmonized is very important because they're tested to interact together. Below grade waterproofing, above grade WRBs, sealants, flashing details, sill plates. So we do offer a gamut, a cornucopia of different options of products that you can put onto your build. Besides insulated concrete forms, we also offer at Nudura, and this is good for the type of construction projects that you guys might be involved in, panelized products. It's not just a polystyrene panel. It has integrated furring strips in it. The under slab insulation. It's not just insulation. It's got these little pucks for alignment for hydronic heating to make sure those are properly aligned. When we talked about ICF on a horizontal plane, we're looking towards this. There's already manufacturers that offer this on the market, but we are actually acquiring companies that are providing this. So for right now, until we have a better name, it's called Nudura. Not available just yet, but coming soon. Something to look for in the future. But what we do have available too also is another kind of ICF layman version, a condensed version, which is called Hercule. Slowly starting to have inroads. So when ICF is just not appropriate, and say if you got a infill wall or something else that just has to have a little less robustness and probably a touch less performance, then you could look at something like this, which is kind of like pre-assembled variants that you erect this wall system, pour the concrete in it, and you've got your not a curtain wall, but an infill type of a wall. And it could bear up to 3 stories of weight. So an interesting project coming or product coming down the route. We're calling it Hercule wall, but it's a division of Nudura. For the people who ask questions about membranes, yes, we do offer different variants, and every product we've got, there's pros and cons. There's good, better, and best. So when we look at the peel and stick type of stuff for below grade, yes, we've got those. And it's been the standard in our industries for a long time. But now we're heading more towards fluid applied. These are either rolled or sprayed applied products. You'll never want to use a paintbrush. It'll just last forever. Yeah, just a joke inside there. I don't know who's laughing their brains out right now. But yeah, roll applied or sprayed applied membranes. Different variances of robustness and exposure to UV is afforded to you. So this is a baseline product for liquid membranes. This would be a baseline product for a peel and stick membrane. If you take this guy here and you need to bolster its UV protection and its robustness, then you go to the next applicable product going up higher. So we do offer a family of different below grade applications. And keep in mind, every product that we're actually providing here is harmonized and tested to interact with the polystyrene on insulated concrete forms. Predominantly with Nudura, we test it with our own products. When we go above grade, I'm sorry, we're still below grade, but when we're dealing with high water tables, clicked on me all alone. When we look at the high water tables, we do have solutions in regards to how do we combat that. If we're already using a waterproofing membrane, but we need to have or accommodate for higher hydrostatic pressure, we do have these glass mat panels that are compressed fiberglass, that these things on a basic version can dispel up to 160 gallons of water per linear foot per hour. Your boat's not sinking at that point. And it can get up to a point that where if you have a really problematic area, it can go up to 350 gallons per linear foot per hour that this product itself can expel. It's not a built up of hydrostatic pressure. Basically, anything that hits this will go straight down that panel. It's fiberglass, but anything that comes into it is decoupled. There's no pressurization. Other product that's really pretty cool is what happens at the grade level. You have exposed foam. You have your siding coming down. Typically, siding will not contact with ground. What to do with that little area that's exposed? We have an elastomeric membrane that has an aggregate in it, and it is a chameleon. It really mimics stucco or acrylic finishes that we're accustomed to seeing. Nothing stops us from using something different. But when we talked about lingering psychologies and calibrating understandings and all that kind of stuff, and using one thing to comprehend something else, that's where this product comes into play. Spray applied, fluid applied, rolled applied as you wish. It's a fluid membrane, that's sprayed or rolled applied, and the aggregate itself. And the cool thing about this is UV stable, very easily to put in place. It's made to interact and overlap with the waterproofing, and it's made to overlap with whatever weather barrier you're using. And it's tintable. You could change its color. If you want that purple, you can have it purple for whatever reasons that you're needing that purple. But out of the box is this little gray slate kind of crayon looking chart. No, I don't even know what the color is, but it's like an off beige. But that's what it comes out of the box. When it comes to weatherproofing, insulated concrete forms is not required as a good solution. As better best, we definitely as a manufacturer recommend it. It's just a great belt and suspenders approach in regards to waterproofing or providing a secondary plane of protection. Again, this is a liquid applied membrane. It's permeable, so it allows the permeability of whatever's behind that to expel itself outwards. And it's very easy to put in place. Having this membrane put in place will also act as a primer for whatever type of flashing or other type of peel and stick waterproofing you're using. So within that, around your openings, we'll have different types of flashing details that we can recommend that actually are backed by a warranty. And you can see right now that it has that weatherproofing on it. The weather resistant barrier, which really is interesting with this, you can see little diamond plates in the background here. They do not camouflage the locations of the anchoring strips. If you're putting a weather barrier, a Typar, or whatever kind of sheet applied membrane on there, you most likely will lose where your anchoring points are. Either it's the sheathing that you're working with or what have you, if you want to make sure it's embedded into a stud. This right here will not camouflage that, and it always allows you to locate where the internal fastening strips are. So it has a lot of good beneficial products. And there's commercial details and there's residential details afforded to you. We have other products for the parapet. This works out really well when you're trying to have that one product doing multiple things. Parapet in homes, I don't know if we do those all that often anymore, but yes, we have them. Commercial building, we see this many times. And when we see this type of details quite often where they have 4 or 5 different products included, keep in mind, labor associated with all this, just to make that slope inwards or outwards. Well, we have a product that does that by default. One step, you actually wet set this in, even better. So as soon as you poured your top of concrete while it's still wet, you lay this atop. There's little holes on top of this plate that allows you to wet set your anchor bolts through that plate. If it's a sill plate at the top of the wall, they're flush. They do not protrude higher than the bucket itself or the plate, which allows you to place your roofing structure anywhere you want it. So we have parapet solutions, we have sill plate solutions, and we also have openings, the bucking systems, all done with this LSL type of construction. All this is wrapped up into a warranty. As Nudura, as Tremco, all the products that we supply to you, if you have a typical wall section and we're hard speccing our products, and if you want to afford this to your clientele, they can apply for upwards to about 25 years below grade, up to 10 years above grade for any infiltration. It's a pretty robust warranty. The cool thing about it is that for the first portion of that warranty, it's the actual applicator, certified applicator, that shoulders that responsibility. they have to have skin in the game for their own work. After that, it's expired, we take on the remainder of that warranty. So this is something we can examine if anybody would like to have more information on our warranty program. And our website. This one I'll probably breeze through just a touch because you guys could probably figure this one out. But within our website, there's different attributes here that you need to be aware of. The first and foremost one that's really beneficial is the resources. So as you're looking through resources, probably if you want to get the design library, from there you'll have our unit form profiles. You'll have different technical drawings in DWG, in PDF, and even if you're working with BIM, we'll have the families available for you. But in the PDF version or the AutoCAD version, you'll have something similar to this for either the form itself, the corner, the straight, and also the different building assemblies that we do for either non-combustible or combustible construction. So this is just a little handful of thousands of details we got on that website within our design library. Going further within the resources, if you look at the installation manual, this would be something that, is pretty boring, but you need to know it. So it's one of those kind of things that, if you're nerdy enough, you'll find it cool. If not, then it's a little laborious. But once you get the hang of it, it's pretty simple to decipher and break apart. Within that, it won't only just give you guidelines on how to position the product. It gives you how to determine wall thicknesses, general layout guides, the wall heights. It provides you a plethora of information, engineering parameters, and also the wall functions themselves. I know this is small, but the wall functions basically is what's the STC, what's the fire rating, how does the vapor barrier work? So this is all those little tidbits of information that is important to justify how we fit. Keep in mind, this is all within that ULC 717. We need to have all these attributes in place with met criteria before we can do that. But if you need to decipher or look down and drill down a little bit further, you can have that within our resource center. I'll keep going a little bit further within the resource center and the installation manual. This guy is really boring, but it's very important. Anybody building within Part 9 that would like to avoid having to have outsourced engineering, within the ICFMA, if you stay within the constraints of this guide manual in regards to pre-engineering specifications, you will not need to have a third-party engineering firm certifying your work, as long as you fit within the parameters of these guides. I will dive into this one a touch more in our second presentation. And then we're getting near the end, so just make sure people aren't walking away just yet. So within the technical support, you can get more information on all the products we've got. And also you could look at the different project profiles that we have. If you'd like to say, hey, what kind of schools have you built? Here it is. What kind of really cool homes have you built? Here they are. So you got a lot of information with that. And the last portion of our presentation, the cool stuff, is that we'll just give you a little bit of a hint in regards to what we do. It's only 4 slides, but they're really pretty cool. This right here, it's a big building. I get it. But the neat thing about this, it shows the hybridization of curtain wall construction and standard ICF construction. 85% of this building is ICF from footing to top of wall. And you can see the subtleties of the nature of that. And we had a very strong implications on the design of this build, to whereas we could actually allow cold joints to actually form the sill of these openings. Allow this cold joint to be tumbled down. So as this is tumbling down, it gets a little bit less gradualer, and it creates our sill. So when we are involved in a project early enough, we can actually accent, optimize, and enhance that design. Residential builds, this is in your neck of the woods. Some people might be familiar with it. Daryl will be more than happy to discuss it. I like this one here because it's got not only just great imagery, but it shows the complexity of this build. How do you actually get that first uniform row going? You can contour it. You can imagine this being step footing. Step footings would be baby steps compared to working with this kind of stuff. So if you're able to accommodate pure rock, undulating, fluctuating surfaces, and eventually get to a harmonized and uniform layer, you're off to the races at that point. So complexity, we can accommodate for that as long as proper planning is in place. And if you want to get a touch more complicated, First Nations projects are definitely a strong suit for us. If you have a spiritual animal that you're trying to represent in the footprint, say be it a turtle, we can definitely accommodate all these changing radii, changing core sizes, and eliminate the need for all this singular use, just one-time use forming system that cannot be reused elsewhere. If we talk about embodied carbon, we have to calculate all this kind of stuff. And on top of that is that your forming system, you don't leave that in place as you would insulated concrete forms. So we can accommodate that. All these radii were done in-house by me. I offer this service. I offer the service to each and every one of you on this call, that if you need help advancing your projects, I'll be more than happy to assist you on those. I've offered 2 other forms of contact here on our website. On this last slide. That's me on the left. I don't always stand that way, but that's the way I took the picture. Kristen is our local representative, and Daryl and Shane, they basically are our representative too. They've been in the game so long that either one of us can definitely speak on behalf of the other without hesitation. So please keep in mind that we don't just offer the nerdy bits of the construction part. We offer a service. The second part of our presentation will explore it and exploit the information that I can share with you to help you start a project. Where's the first step that you go? What's the consideration? So the part 2 might be more in line. Now that you guys have eaten your vegetables, the dessert will come next time around. So I hope that at least sets or primes the surface to allow you guys to better enjoy the next version. The next version, I promise you, we will look more toward design, prerequisite criteria, everything that allows you to make that beautiful plan for your client. So if you guys want, I'll be more than happy to take some questions at this moment.
Yeah, that was great, Eric. Thank you very much. There's some good questions in the chat that maybe we'll just run through, and then we'll open it up if you want to raise your hand if you have specific questions. Some might have read the answers already that were given by Daryl, but it would be good just to review these. Bill was just asking about the taper top walls. Now, part 2 is going to deal more with the technical aspect of things, but just Daryl, do you want to just give your answer that you gave to Bill for the group?
So basically, a taper top block has an additional 2 inches in width of concrete at the top surface, which creates a larger bearing surface. So often we have people that will just use their ICF for their foundation, and they'll have wood framing above. So that allows you to have your framing flush with the outside of the foam, as opposed to using a standard block where you would typically have a lip of foam that you have to flash.
Great.
Now,
Okay.
I'll have those details available too on part 2. Again, we're always teasing for part 2.
Yeah, and just for our group, if you missed the section, how do you get those resources? On our website, in the resource section, there's a link to the resource page as well as the contact phone numbers for the Nudura and Island ICF team. So you can check out the resource section there and then get the link to where you're trying to get to if you missed that. So, okay, let's look at the I think the question there about the perfect footing also from Bill. Daryl, what was your answer on the footing tolerances?
It's recommended to pour your footings within a 1/4 inch of level, and that just basically saves you time, because with ICF construction, you build the wall up row by row. So when you get to the top of your second row, our wall's 3 feet high. That's where you shim and level everything and get everything dialed in. So obviously, the more closer the footing is to level, the less shimming and prep you're going to have to do.
Great. And then Pam's question. So I think you answered that. How are we specifying this? Your team is available to call if you're looking for specific details or have questions. I know from our experience with Nudura, in the resource section, you can find pretty well any scenario you're looking for. So there is some great CAD details to download. We were talking about this the other day, Eric, as well, that the Nudura CAD details are not filled with millions of points of CAD details, so you don't have to worry about them bloating your CAD drawings. They're nice to import.
Yeah, I'll just allude a little bit on that too. Yes, they are fairly basic, but part 2 will explain how to really trim the fat off of those details to incorporate into your standard design layouts. They're great to have just to show that particular detail if you really need to have eccentric detailing. But when it comes to typical drafting, I'll explain how I do those. but it is a service and an option that we offer and afford you guys to reach out to us directly, either through Daryl, Kristen, Shane, or myself directly. But if you give the West Coast team the first shot, because they'll be closer to you, but they know very easily how to reach out to me. And the detailing we have on our website, they're very generic, they're open source, they're applicable to everything. If we need a bespoke detail, something specific, how would you address this? You can simply send us the detail and we can respond to you as a manufacturer's recommendation.
That's great. Yeah, that's wonderful research. It's one of the reasons why our company switched to Nudura. I was mentioning this to Eric, is because of the resources and also the customer service. If we do have had questions of that nature, it's very quick response. So Bill asked a question about separating walls, so party walls within multifamily. You did deal with that. What are you, for your 2-hour walls, is it required a 6-inch form, or can you pull off a 4-inch form if it's for a 2-hour rating?
So we could do it, and Daryl, if you could jump in, you can interrupt me if you want. But the fire resistance rating, there's two folds to it. There's a ULC at 101 and there's a 124. So there's different, again, all those required ULCs to get into the building code, we acquire those. So the 2-hour fire resistance rating, we could have that on a 4-inch core. We could have up to 4 hours fire resistance rating on anything above. Keeping in mind that 2 is a max. At 4, they cut off the switch. There's no need to go more than that. But that's the concrete core. Now, all that is dependent on the ULC 124, which actually provides for and explains the requirements of a thermal barrier. You cannot have just the foam exposed alone in a habitable suite. You have to have a thermal barrier on that foam. And that's just as simple as a 1/2-inch standardized drywall panel, gypsum board. Sorry.
It's not required to be type X.
No.
Yeah.
No.
Because your fire separation is the actual concrete.
It's the concrete, but also the thermal barrier protecting the foam.
Right.
So you need to have, and then once we get a little deeper in that, if it's a party wall, next we have to start thinking about STC values. So to get an STC value, I don't want to just have a 6-inch core. And again, Daryl had alluded to earlier, if I'm burying another flooring system, I could use the taper top on either side and get more bearing atop, but I don't change the profile of that 6-inch exterior measurement. But if I'm trying to get a better STC value, I may have to isometrically build that wall assembly. On one side, I may have to introduce a resilient channel because we're trying to avoid that tambourine effect in the wall itself. So even though the wall is fairly robust in providing that, it can resonate, reverberate inside of that wall assembly. So we don't have an STC value. We have an ASTC value. So it takes into account the flanking and what have you in regards to that wall assembly. But fire rating is done through the 2 4-hour ratings is done through our ULC 101. And then the 124 alludes to the thermal barrier. You have to have the drywall on the wall to get that fire rating complete.
Yeah, and that's I'm glad you brought that up, because the ASTC rating is important, because you're not dealing with that flanking sound that would come through the floor system. So just bear that in mind when you're speccing it, that you want to compare the ASTC rating to the wood frame options that you have there. And I'm glad you say that the 4 inches is appropriate, because that's a lot of times in the tight multi-units, if there's requiring a 6-inch core, if that's what the details from the manufacturer are, then you're pushing that wall out to about 12 inches wide, but a 4-inch, you're just over 9 inches, which is very similar to a double stud wall. So that's great.
But it's probably worth noting that we don't see 4-inch all that much in Canada.
No.
Predominantly Northern North America, neither. Again, it just requires, if the engineering permits it, there's absolutely no reason by way of fire resistance rating. We know that 4-inch wall can accommodate it, but we need to make sure that the engineering backs up the permissibility of using 4-inch in that particular situation. If it's not a load bearing wall and you're doing, because there's a pull off value, how much that joist is pulling on the wall, that deflection that you have there. If you're lining up your structural flooring elements in line with that party wall, I could see that you could probably get away with it.
Yeah, that's great. And it's good to have the options, and then you can explore that with your team. So there was another question here. Daryl answered that one. Ken Rempel asked, my local building inspector is asking for full peel and stick coverage on the exterior side of an ICF. I asked why, and he said because of bugs. Any thoughts on this?
We have a pest control agent inside of our forms available, not by default. Having rodents, I think it's more for rodent. What do you call it? In French, gruger. Sorry, I do fall back into French. And they just munch on stuff.
Termites? No.
Not termites, because we do have termites in Canada, but no, because they don't eat. We have absolutely no nutritional value, but they can channel. So that would be, that's probably why they would want to have that in there. But no, I would say that peel and stick is there predominantly waterproofing. Now there might be different stipulations of different municipalities because they have a problem with that. So it could be that there's some kind of built-in municipal regulation that requires that. Do they don't eat through the butyl, the membrane that makes a peel and stick? I'm sorry, I can't answer that one clearly.
Okay, so that might be one we can discuss, Ken, further. I can say that there would not be a unique municipal, although the HDA has the final say on what they allow. They can't go beyond the code requirements in requiring something. So if we could maybe look at that.
We find all the AHJs often, when it comes to commercial builds, we have to rely on the AHJ. I'm trying to think of the product we put in our ICFs down south for termite control. I can't think it off the top of my head, but if ever there is a need for that, we could find a way to have that in there, but then that counteracts what we're trying to do with the ecology. But again, it's not something that leaches out. So if someone has a real high problematic issue with that, I would definitely invite them to reach out to one of us to see if we can actually, if we can't provide the answer, can we learn from this? Is there some kind of little sticky point that we're not aware of?
Yeah, that's good. So what is the R value? And I think the answer was there, R22 now, or R24. Now your R24 though is an effective R value versus a nominal, or is R24 your nominal?
Now the prescriptive R value is going to be for the product alone, or standard product is R21. Before you start assembling it and putting a bunch of stuff into it. But the effective R value is that ASTM value. Where we have difficulty with that ASTM 1363, our advantage is our downfall. It took us that 16 or 13 somewhat days, 320 somewhat hours to find that steady state. But once we hit steady state, that's our R value. So it's 24.1, I think, on that book alone. But we can use that information preceding it, that 7 days or 5 days worth that says we perform at an R value higher than the theoretical value. So in the conclusion of that test, which is available on our website, Caleb Laboratories does make that conclusion in regards to this wall is performing much higher than its theoretical value, up to like 60% worth. So again, it depends who's extracting what information from where. If we're looking prescriptive R values, unfortunately, what we have to work with, then at that point, either if BC has their own, I know in Quebec we have Nouveau Climat, and we could put an input, in wall segments inside of that program, and it'll spit out an R value, an effective R value. But again, we know that it's just not attributed a proper amount of performance value.
Yeah, well, and I asked that question because if you're using R24 insulation in wood in 2x6 studs, for example, that's the nominal R value of the insulation, not the effective R value. You're losing it on your studs. So if your R24 is effective, an R24 insulation in a 2x6 stud is not going to be equivalent even at that rating. So
completely correct. And keep in mind that's 2 pounds of mass versus 75 pounds of mass. The inertia, the thermal lag is I guess it's the official term, thermal lag, that's involved in that. That bad insulation will never be able to produce any kind of inertia.
Right. Now, Ken had the same question I had. How soon for new Duradeck? Because we all are doing suspended slabs over something these days. So
I'm trying to look. We do have our samples. It's on our website. It is available. Again, we have to. It's just now coming out of incubation. The product has existed for quite some time. It's an acquisition that we've acquired. So it does have pedigree. And it does. We were looking at different depths. It looks a lot like the Amdex, the Insuldex, and it's the same kind of feature. When it's going to be available, Daryl will probably be a little bit more to date with what's going on with that, but it's something that we've got to work on getting more statistical information on code approval, code compliances and things like that for Canada. We've got everything in the US.
We are
Right.
going to be having a live demo at our warehouse on Cobble Hill on May the 12th. It's going to be an open house type situation.
Okay.
So we're actually going to build a Nudura wall and then show the waterproofing, show some XOR tape for window flashing membrane and so on. And then we're going to build in the afternoon, we're going to build a Nudura deck suspended slab.
Great. Well, Ken or Daryl, if you can send us that information, we'll put it on our upcoming events so that members can join in. I did put in the upcoming events here, the part 2. So if you haven't registered, part 2 will be the more technical presentation. And I think that is the one that if you have signed up for this one, that's really the one you want to get, in my opinion. So sign up for it. That one there as well, if you have builders that you're working with, or anyone else you think would be of interest, you can share that presentation with them. It's not just for our members, these Nudura presentations. So please pass that on to whoever you think would benefit. And then, of course, we will have the recorded program for the members. Okay, if you have a question, at the bottom of the screen, there's a reaction thing where you can choose raise hand. So put your hand up. Until I see questions, I have some questions. You showed pools earlier. Do you have any pre-designed pool packages that are available? Because
Yes.
we're doing pools all the time.
Yeah, there should be. I don't know by memory, but yeah, within our resource center, you'll have snippets about pools. Oftentimes, I'll have. Like Daryl and I will discuss quite often, can I produce? Because even though I'm responsible for developing awareness for our product, my title does not represent what I actually do. I'm kind of like the Joker within Nudura, is that I do a little bit of everything. And the main thing I do is a lot of presentations, a lot of product awareness. I do a lot in regards to advanced thinking. Where will we be in 3 and 4 or 5 years? So the other skill set that I bring to the table is the architectural side of things. And so I'm the guy creating those bespoke detailings. We have another team down in the States that does the generic stuff, the stuff you see on our website. But then when, say, if you guys reach out to Daryl, he's got something. He's like, man, I need Eric on this one. He'll reach out to me, give me the criteria. I'll send back an illustration. The pools are the same manner. We have this general packaging that explains it. We don't have caps or drains or anything like that, but we explain how to do it. Now, if the project merits certain attention, we do make the drawings. We optimize it. We show the different levels, how to step down, how to get to it. The only way that we don't go any further is that when it talks to the membranes, what are you using? Is it an insular? Is it an actual fiberglass, bucket that you're putting in there? So things like that we look at. But yes, I got one on the table right now I got to do, but we have general information on our website. If anybody has like a pool installer that has multiple pools and they have a couple of designs they want to alter, reach out to Daryl and then he'll be able to segue to me.
Nice.
Or you reach me directly, but I'd love for you guys to speak through Daryl or Kristen.
Perfect. Okay. Then we get into above grade because, like you mentioned, we're doing a lot of below grade foundations, probably where ICF's being used the most. Above grade, what are the thicknesses of the forms? Are you seeing primarily on a 1-story, like 6-inch, or are you using 4-inch forms? What's your?
Yeah, predominantly 90. And again, keep in mind, 4-inch, we rarely ever see that. The 4-inch we use as infill walls sometimes on platform construction, stuff like that. But a 4-inch wall, not to say you can't do it. It's just that, our codes will minimize, I think it's 5.5 inches that we're allowed to have below grade. And so beyond that, I would say that booklet, I don't know if anybody can see me, but this little booklet right here, it will give you parameters in regards to how to choose your core size. And I would say for the most part, not the super heavy seismic areas, the majority, well over 85% of the builds we do, it's 6-inch core for 1 level below, 2 levels above. I've got a multitude of projects that we're going up to 6 stories with 6-inch core. that involves engineering.
Okay,
So-
I gotta jump in here because in our area, of course, we're blessed with having the highest seismic zone in Canada. So most engineers will default to 8-inch even for above grade. So we sell a lot of 6-inch product for party walls. We sell some 6-inch for above grade walls for usually ranchers, 1 story. But a lot of the local engineers do defer to, or 8-inch for any above grade.
Yeah, in that manual, it'll dictate what core you use and what the manual will give you by location what your seismic acceleration is and your wind factors. Once you get those in place, the manual will tell you what core you can have. But again, keep in mind what Daryl just said. The engineer of record will override that if they need to. But to answer your question simplistically, nationwide, 6-inch will be the majority of what we're using. But keeping in mind what Daryl just said, if you're in a high seismic area, or if you're adjacent or really close to it, your engineer may override what our charts say anyways. But again, keep in mind with your local authority having jurisdiction, those will dictate. But Daryl's site knowledge will definitely lend well to saying no, this is pretty much 8-inch at this particular situation. But 6-inch by way of code, by way of our manuals, a good 80% of the bills we do.
We do.
Well, and I'm glad you bring that, both of you bring that up, because we have members here that are in high seismic areas, but we have quite half of our membership is in the interior where the seismic levels are less than the wind. So they're not designing for seismic, they're designing for wind bracing. So in those cases, still the default for many of them, the engineers use 8-inch. But you can push the engineer to just think a little harder and use 6-inch, and then it makes the ICF blocks more affordable because you're reducing your amount of concrete. And that's we used to use 6 when ICF was newer. We used 6 all the time for foundations, but I've noticed even with the projects we work on more and more that just people are defaulting to 8-inch, right? So
again, I think it just depends on the engineer, your shear wall availability, and the height of your below grade walls. We have a job specifically right now in Shawnigan Lake, where the basement is 10-foot ceilings. So we have roughly about 12 feet of backfill on the one side. So we've transitioned, and our engineers allowed us to transition from 8-inch below grade to 6-inch above grade. Of course, the steel details are a little bit more stringent as opposed to the 8-inch, but at the same time, like Tony said, the cost above grade, you're shedding 25% of your concrete cost. That's a substantial number in the long run. So depending on the engineer you're using as well, I find, they can vary. So we have some good engineers that we work with here in Victoria that we can refer to you, designers, to explore your options, I think, and see who's going to work best with you. Steve from Far Hill is the engineer, particularly working with us on this project in Shawnigan. And the steel details are a little tight, but I mean, at the same time, the 25% concrete savings is a substantial number. So it's a bit of an offset. But
yeah.
That's the one thing that's good about our block is that you can transition from 8-inch below grade to 6-inch above grade. So there's value there as well.
Yeah, you can transition also in plan. Say if for any reason you have a higher backfill requirement, then you're coming out to a walkout condition, what have you. As you turn the corner with the 8-10-inch, whatever you're using in the reinforcement area, you can trim it back down in line if ever you need to. So you can change core sizes either in elevation or in plan.
Yeah, that's right. Yeah, good. Okay, and then I don't see any hands up yet, so I'll keep going. I like the point too that you have that your ICF blocks act as the air barrier, because as we transition to step 4 and step 5, it's all about air barrier, right? So if you can have the air tightness, so your air changes per hour is like, I think in your documentation was showing 1.1, 1.2 air changes per hour.
Yeah.
If you're hitting that target, and you've got the air tightness on the building, then that upgrade to step 4 is really easy to achieve. And right now per unit, there's a $20,000 payback from BC Hydro and Fortis if you hit step 4. So that offsets too. Like the customer pays a little more for the ICF block, but they're getting back because they're hitting a higher target. So you have
Correct.
you have to look at the whole building as an entire system rather than just components and say, okay, by doing this, what am I saving in the other places, right?
Yeah. And keep it in mind, it's the concrete that's doing the majority of that work for the air barrier itself. Now, if you want to refine and tighten up the flashing details around the openings, that too will trim it down quite a bit. You'll take a lot of fat off of that air exchange rate if you want. And then going to the better, best scenarios where you're actually applying that fluid applied air barrier, you're tightening it up even more. So, basic design will give you that 1.1. But if you want to bring it inferior, 0.5, we've got passive houses that are even better than that. You can, depends how much effort you want to put into it.
Yeah, that's great. Okay, then I was going to ask about the grid systems, but you have your Hercule. Is that kind of a grid system? Then would you consider your Hercule a grid ICF form?
You mean in by way of the waffle or grid? Yeah.
Yeah.
So when I alluded to that a little bit earlier, yes, not the same type of manner. There'll be an inferior beam, there'll be a superior beam, and then there'll be columns coming down at every, I think it's 12 inches.
More of a column form type.
Yeah, and then that itself will be able to bear weight. It can carry a couple of stories on it. Daryl, will you have that during your are you said I gotta be careful with the distributors. I don't know who's taking what.
Well, I'll tell you why this is of interest to me is because we do projects across the province, like many of our designers, and we're doing a lot of projects where concrete is not readily available, but also with very high insulation requirements. So
Exactly.
if I'm doing something up on the Yukon BC border, if there's forms available where I can cut the amount of concrete in half and they're running one truck rather than multiple loads, then these things become really important.
They're important, and they're also pre-cut too. They're site specific. But once you buy them, They're yours. So if you change your mind, you've got them.
So just to clarify, I honestly haven't studied Hercule too much because, again, with our seismic area, it's unlikely that we're going to be able to sell that product here because it's basically it's almost like a 4x4 post of concrete every 2 feet or whatever it is. So they apparently have been working on it, but it seems like it's not going to be able to achieve what we need to do for above.
Yeah,
and that is only for above grade construction, Tony. It's not a foundation product.
Right. Yeah.
So it's just a panel. It's going to replace wood framing, but light and very modular and easily put in place. But because the minimal amount of concrete with the system, apparently it's hard. It's a barrier to them achieving what we need structurally for our area, but other areas like in the interior, it's probably okay.
Right.
Yeah, code validation is underway with it and with the Nudura or Light Deck. Again, we have to have these validations in place. So when we're looking at exactly how much does that contribute to the diaphragm of that build, we'll see. But it does have integrated reinforcement inside of the form itself. So basically, they're pre-cut and the reinforcement's already in there. That reinforcement becomes this anchoring strip. There is a substantial amount of metal involved with that panel, but it's an interesting option. And as it evolves, everything can improve and get validation if ever we do a tweak. So again, it's coming out of incubation towards Canada, but it already has its pedigree in the States.
Right. Okay. I still don't see the hand, so I have one more question, and I'll give a little bit of the background with it because I don't want to just dump it on you. Going back to party walls, when you're doing a multi-unit, we're doing a lot of infill now with the new government, the government making infill possible 4 units per lot. So on a lot of these tight little lots, we're fitting in 4 unit buildings that are where a house would normally go. So we need to do, in most cases, a fire flow calculation and FUS calculation to determine whether or not there's enough water coming to the site to put out a fire. The FUS calculations allow that if there's a 2-hour party wall in between the units, it will reduce the amount of water and sometimes will allow you to do that building without a sprinkler system, because in most cases a sprinkler system is required. So my question for you is, do you know with the ICF, do you have any documentations that go along with the FUS requirements for what they consider a 2-hour party wall. For example, does your product, I think in one of your comments here from Daryl was that the ICF goes to underside of sheathing on the roof. Does the ICF, to meet the FUS requirements, need to penetrate the roof? Do we need to cap over it? Have you had that question asked before? Because that is probably going to be one of the number one things in the province as people are doing more of these infills, running into how can I avoid sprinklers? Do the ICF party walls make the decision? And now that's a lot of ICF.
Yeah. Now we've had it to a point where we've actually run the ICF up and was it 6 or 9 inches above the roofing system itself to create that physical fire separation between the two builds. So it depends if we're looking for a fire rate assembly or a fire wall, party wall fire. There's going to be distinctions between those two, and how high up does it go? We've had multiple times where top of concrete's always been consistent all around the building and the party wall, and then they'll continue up with just a standard stick build with fire rated on either side to make those separations. But how do you protrude and penetrate through the roofing system? So yes, we've seen ICF used in that exact condition where it just extends upwards and beyond the roofing system. It just follows it's like an expanded gable that allows that. Now, the rating itself in regards to how the ceiling is being treated for the physical fire separation itself, I must admit I'm not familiar with those regulations that you've got. But if I was afforded a detail or at least an article that shows that, I could find that we have compliance. And I can't say that we have it for every condition, but afforded that kind of information, I could see if we have a documentation that finds compliance.
I think that's one of the things I think I'll talk to you a bit further about, because the problem with the FUS requirement is it's vague. It's vague as to whether that can end at the underside of the sheathing or needs to penetrate. So if Nudura was to get a hold of Fire Underwriter Services and find out, like, what are you asking our walls to do, and provide a Fire Underwriters approved detail, then we could give it to the building officials, because it's what happens. It's like, okay, well, how high are we going with this ICF wall?
Yeah, if they're treating it as a firewall or fire separation, then at that point at least by way of code, it determines how high up it needs to go beyond the roofing. Is it underside of sheathing or is it beyond the roofing?
And
so we've got for the infill projects. There is a little tidbit that maybe I could tease this one, but there are requirements in regards to our limitations. So it would be important that the next batch over that I discuss where we don't fit. There's some places Daryl alluded to it earlier. We can't be greedy and say we fit everywhere. There's going to be some places where it just don't work that way. So if it's always good to speak with your local distributor that are going to have a lot more education in that particular, more refined information. I could take a global perspective, but again, when it comes down to infill lots and how close you are to your lot line, there's going to be unprotected openings that need to be considered. And so, I'll add that in my thing here in regards to how to identify a proper build, predominantly when it pertains to spatial separation and the percentage of unprotected openings.
Yeah. So Tony, just to answer, hopefully I can answer your question.
Yeah.
We had a side-by-side duplex that we supplied in Colwood outside of Victoria, I don't know, a year and a half ago. And normally these things are determined by the architect and the engineers before we even see the plan. We're just selling product, right? But maybe Eric can come up with a detail that can, like you say, Tony, that is kind of universal, that can be downloaded. But
Tony, if you want, he could send it to me beforehand, and maybe I could draft it real quick just to complement our discussion.
So maybe for part 2, we could come back on that one.
Yeah.
In this particular case, the builder had a discussion with the building inspector or I guess the architect, and they actually extended the ICF up about 16 inches through the roof. And then there was no requirement for fire sprinklers at that point.
Yeah. And I think that's if we had something official, because it's really when the AHJs are trying to make that determination, there's that lack of clarity with the FUS requirements that it would be nice to have something a little more uniform that we could show as
send the article so I can look at the language. Specifically, are we referring it to a firewall or fire separation?
Yeah.
and I could see, what kind I could produce with that. That'd be a good topic for the next one. I mean, this just shows. I mean, this is a testament to what these guys, we're willing to help you guys out with, especially now that we're involved with and we're part of the family.
So I'm pushing you. This is it.
I
I'm testing out the
I feel like sometimes it's all in the eyes of the authority that like governing body, like your municipality too as well, how they're deciphering it. Like you said, Tony, it's fairly vague. So, just for instance, we had a 15-unit townhouse complex in Langford, and that we were kind of under the gun there. We had to do a separate service, 2-inch service to the subdivision. Every unit had to get sprinklers. We opted to go to the municipality and we dealt with them along with the fire chief, and they came to the conclusion that it did meet their criteria to alleviate the usage of sprinklers. So we had 15 units, and essentially the cost of our service and the cost of our sprinklers per unit paid for the entire ICF for the foundations and the party wall for that entire project. It was huge. It was about $80,000 in the end that it saved us. And that was a project that I did personally myself. And we've had Langford and Colwood request certain documentation. And again, exceeding the roof line by 16 or 18 inches. And then in some cases, that firewall might come and protrude through the front of the building and the rear of the building to give that separation that's needed. But we can get you whatever documentation you would need. And I think it comes down to making sure that the municipality or the district that you're working with has that information, and then working with them at design to make sure that these questions are answered. And obviously, the last thing you want is to put a bunch of money into a project and then have questions after, which we've had, and it's a bit of trial and error. So, yeah, it's something that we could probably definitely touch on next seminar and dig into a little bit more too as well.
Yeah, and we have part of our membership. We have about 120 building officials as members beyond our designers, and
Oh,
so those
fantastic.
resources are great, not just for the designers, but the building officials. If they can pull up and see, okay, this is what the interpretation is like, and this is a detail that works. So that's what we're trying to have for our membership, is just easy access to be able to make products like this usable, right?